You know that old familiar handbrake lever we all grew up with? Well, it's pretty much disappearing from our cars, and it's being replaced by this slick little button. Today, we're going to demystify the electronic parking brake, or EPB. We'll get into how you service it, and maybe more importantly, what on earth you do when it decides to just stop working. So let's just dive right into the big question, right? You pull the little switch or you push the button and crickets, nothing happens. Or even worse, it's stuck on and it won't let go. Your car is completely stuck. So what's your plan then? That's exactly what we're here to figure out. Okay, so first things first, we've got to understand what we're actually dealing with here. It looks incredibly simple on the outside, but believe me, there's a lot going on behind that little button. I mean, on the surface, you totally get the appeal. It's clean, it frees up a ton of space in the console, and it just feels, well, modern. One little pull, one little push, and the brake is on. It's user-friendly design at its absolute best. But here's the thing. That simplicity, it's kind of a clever illusion. And this right here, this just shows you the reality of it. Underneath that one simple switch is a whole network of wires, control modules, and little electric motors. We're not talking about a simple mechanical cable anymore, folks. This is a whole different beast, a really sophisticated electromechanical system. So here's the bottom line, the crucial point. An EPB is a computer-controlled system. You've got the switch that you pull, an electronic control unit, or ECU, that's the brains of the operation, and then an actuator motor right at the brake caliper that does all the heavy lifting. Okay, so how in the world do you actually work on a system that's this smart? Let me tell you, servicing an EPB takes a totally different mindset than those old-school mechanical brakes. Yeah, you can't just grab your trusty old tools and try to force that caliper piston back to swap out the brake pads. This system is smart, it's active even when the car is off, and you have to follow its very specific rules for maintenance. There's no winging it here. Now, this is where it gets really interesting. Check out this process. To do a simple brake pad change, you have to plug in a scan tool and basically ask the car's computer for permission. You put it in service mode, the tool then tells the little motor to electronically wind the piston all the way back. Only then can you do the brake job. And when you're done, you use that same tool to readjust everything and clear out any fault codes. So yeah, that scan tool, it's not a nice to have. It is absolutely essential. No way around it. All right, so everything's great, right? The system is convenient, it's smart, it just works. Until, it doesn't. So what happens when those electronics decide to take a day off? And let's be real, with any complex system, it's not a matter of if something will go wrong, but when. And when it happens with an EPB, it can be a massive headache. And this is the real problem. A dead battery, a bad switch, maybe a chewed wire, any of these can cause a total electrical failure. And if that brake was engaged when it happened, well, it's going to stay engaged, locking up those rear wheels. And just like that, your car is basically a very heavy paperweight. It's not going anywhere. But hey, don't panic just yet. The engineers who designed these things, they're smart. They knew this could happen, so they built in some emergency overrides. You just have to know where to find them and how to use them. Now, depending on your car, you've got a few different ways to tackle this. Some cars have a special tool that you use through a little hidden panel in the trunk. Others have a good old-fashioned ripcord, like an emergency release. You could even try to power the motor directly, but you gotta be super careful with that. But the most common fix? Well, that one involves getting your hands a little dirty. And I gotta say, I love this little detail from the source material because it really puts the manual in manual override. One of these methods can take 300 turns and up to 20 minutes of cranking away by hand. So yeah, it works, but it is not as simple as just pushing a button, that's for sure. So let's walk through how you'd actually do this on a lot of cars out there. First, you get the car jacked up safely. Then you find the little electric motor on the brake caliper and take out the bolts holding it on. After that, you can carefully wiggle the motor off, and that'll expose the drive spindle inside. From there, you just use something like a Torx bit to manually turn that spindle, which winds the brake piston back and, finally, sets you free. All right, awesome. The car can move again. But, and this is a big but, we're not done yet. Now you gotta put on your detective hat and figure out what went wrong in the first place. You can actually start with your own 2 ears. Sometimes a change in the sound that motor makes, like if it's straining or making a weird noise, can be a huge clue that something's about to fail. But to get the real story, you gotta go digital. A proper scan tool tells you everything, reading the fault codes and checking live data, like how much power the motor's pulling. And this is super cool. Some of these systems basically have their own built-in diagnostic tool. If something goes wrong, the little light on the EPB switch itself will start flashing out a secret code. As you can see from this chart, you literally just count the flashes, look it up, and bam, it tells you exactly what's wrong, whether it's low voltage or a bad motor. Pretty clever, right? And that brings us to this final thought. The button, the EPB, it gives us all this convenience and a nice, clean interior, but what it trades away is that rugged, dead simple reliability of the old mechanical lever. You know, as our cars get smarter and more packed with computers, it really makes you wonder, are we, as owners, as technicians, are we really prepared for all the new and much more complicated ways they can break down? Something to think about.